Hey guys, it's Chris Love. It's been a while since I've recorded a video for my YouTube channel, and I thought I would try to show off some of the new F12 developer tools in Internet Explorer 11. And I thought I'd have a little fun with a site from a product I saw on Shark Tank Wednesday night, which was, or Tuesday night, which was a couple of nights ago, that, well, the person was very interesting, I'll say the least. The product, I don't know. But I went to her website, and as I'm wont to, I see things and I'm like, oh, I've got to figure out how they do stuff. Well, how you do that initially, well, the developer tools and any of the browsers are great places to start. So I thought I'd actually kind of go through this site for the Cool Wazoo product I saw the other night and just kind of see how it works using the F12 tools, because I like to kind of hack at stuff. The site it's got a lot of things that I think need to be worked on. But what first caught my eye is it's a single page application. Big thumbs up. Love my single page application stuff. So that made me even more intrigued. How the heck does this site work? Well, all right, let's start off with the F12 tools, something I love. Right click, inspect element. Yay! We finally got that. And it should pop up the F12 tools. There we go. And this is the, wow, they're using a paragraph tag for the navigation. That is scary. Okay, so they have a paragraph instead of a div for their nav. Do they actually have a navigation item? This is sort of how I will go through and break down sites. I should have a nav tag up here, but they don't. So it's a little old school. It's not HTML5 using stuff, even though it is a single page app. Go figure. But we can see how the styles are applied. They've got some inline styles for width auto, line height 50, and then they've got some really ugly selectors. Man, never ever have a selector that looks like an old ASP.NET view state or control ID tag that's like forever long. That's way too big. Be a little more direct with your selectors. Also makes it easier to kind of override, use the actual cascading stuff, maintain. But I can see these with the F12 tools fairly easily. Now, if I say I turned off the width and the line height, we go back to that, we can see that now that is just really tiny. And also note that now that I have that element selected, I've got some lines here kind of identifying where this element actually is. So the little, I don't know if you can see it, but this is like a light blue line that goes on the outside of the text. That kind of shows you the boundaries of the text, and then the actual boundary of the element is this orange. It has nothing to do with the background color of the element. That's just what it is. And then it's also got horizontal lines here marking the top and the bottom. So you can kind of see how they line up with the rest of the stuff on the page. So that's pretty cool. Let's go back to the tools. And obviously I turned that off dynamically. I could change this, so if I wanted to, I could bang it out. Come on. There you go. Let's make it 200 pixels. Boink. We go back. Now it's really wide. Of course, if I had these kind of shrunk down, I've got my screen resolution pretty small for recording purposes, but this is pretty cool. If you do have layout issues in Internet Explorer, these developer tools are fantastic for solving those issues. I do a lot of responsive design stuff now, so a lot of times I'll have obviously my browser, and I'll just kind of gradually size it till the the content bonks on me. And at that point, I'll adjust the CSS and stuff, and then I'll make a new rule inside of a media query to actually drive how the layout works. Let's just kind of keep going with this. I've got a trace on all the CSS because I can kind of see where it's actually getting that style from a little easier. Obviously, I could see that here as well, but it's kind of a long path. It's just a different way of looking at how the CSS actually gets cascaded down to it and stuff. So that's pretty cool. And the computed, from the best I can tell, is well, let's see which one's longer. Yeah, the computed. Computed actually is the overall styles, and those are including the default browser settings, I think, too. Here's a cool thing. If I wanted to, say, get all the styles with left in it, I could just type that and filter it. That's pretty cool. Helps me find stuff really fast. That's not there on Trace. It's not there either because It's just the different way they're structured. This has been around for a while in the F12 tools. Most of the CSS stuff does. Anyway, but again, it's a good way to actually see how the element is positioned box-wise, what the shape and stuff is. Here's the padding inside. If we got a border, any margin, and of course the offset from where it actually should be. And here's something that I think is new. If that element has any events bound to it, you'll see them listed here. We don't actually see any here. I wonder if there's any on some of these other elements. Doesn't look like it, but you get the idea. There would be a list of elements here as well. So, alrighty, let's go look at. Let's go see what that does. If I turn that off, the highlight boxes over here are also turned off, which is kind of nice. Gets it out of the way. I have to remember that when I'm doing presentations. I keep forgetting that. And then, of course, I could manually go select an element on the screen too. Now, got the normal the console experience that we're all used to seeing. We also have the ability to filter the messages that are being, console.log.error. Whatever. We can filter those out, and we can also clear as well. Down here is the actual console thing. So I could do 1 + 2, and that'll spit out 3, obviously. But I could also do things like this, 0. And that actually gives me a markup for the last or the current element that I'm actually got selected up here in the DOM Explorer, and that's pretty cool. But watch this, DOM. This would work. There we go. It's the previous one, and then DOM 2. You see how this works? It gives me actual access to that markup, so I can actually see that. It's a neat little trick. You could let's see, 0.inner width, I believe, works. Don't. Oh, it's because I got 3 ends. Oh well, I thought that would work, but I guess it doesn't. Oh well. But at least the markup's there. You could actually do some other stuff off that. Chrome supports all that. There's a bunch of other things that I'm not going to go into. There's a lot of other commands you can drive that are kind of new to IE11. I don't think they're actually part of Chrome either. So here's our JavaScript debugger. My mouse will work. If I'm having mouse issues last few minutes. But so here's the debugger. Here's the core markup. I'm not going to do that. Here's a bad thing right here. They should not have this tag in there. Well, not like this. They should have IE Edge, not 9. You don't want to make your site compatible with something that's outdated. Hello? Do IE Edge. You don't need that Chrome 1 thing in there either. Just do the IE Edge. Make sure it's the most current engine that you can possibly use. You don't want to use an outdated engine. So effectively, I'm using an outdated engine. Let's go see if I can fix that. See, here's the problem. All right, let's go make this actually render in the good engine. Let's go see what it does. If I can Alt-Tab over. So it's reloading. Notice it's slow. The site is slow for various reasons. We'll look at those here in a second, but as you can see, it works just fine, which is nice. They need to fix that. Okay. All right. Back to the debugger. Meanwhile, back to the debugger. Okay. Here's all the JavaScript files. This is one of the reasons why the site loads so slow. There are a ton of JavaScript files. Bad site. Bad. Come to one of my web performance optimization courses. Your site will load in a second when you're done, guaranteed. But here's minified. Let's go look at this. So we've got one of those beautiful minified JavaScript files that the machine loves, but we don't. This actually isn't that. Wow, this is a very small file. But let's go prettify it. Here we go, boink. And that really didn't show the effect so much. Let's go find another file that may be minimized. Usually sites like this have like 4 versions of JavaScript we can go hit, or jQuery. Let's go see if there is. There's a libs. This has probably got jQuery in it. Oh, this is nice and long. Look how big this is. There we go. And it's going to take a second. There we go. Doesn't completely unminify, but it actually does structure it so it's easier to read. So you can actually set a breakpoint here instead of just line 1, right? And that's what we want when we're trying to figure out a bug. So that's a cool new feature. I think it's new. Of course, you can change breakpoint. You can set conditionals on breakpoints in here. Let's just go set one another and condition. And you can say 1 equal 2, and it obviously will never be true. So this breakpoint's never going to get hit. But yeah, you can specify how many times through, I think, and stuff like that. Obviously, when we're stepping through, you get normal debug functions. I always feel like the Chrome dev tools are out of whack because they're not in line with what I'm used to. But F11 steps into a method, F10 steps over a method that you're looking at, and then that steps out of a method, which is stuff if you're doing normal debugging like C# you're going to get into. We can do word wrap. It just makes it so you can see the whole line. That's nice. I could pause debugging. I could go find stuff in files. So let's go say number. And this is nice. It shows every little line that has number on it. So that's pretty cool. You can set watches. You can just quickly add a watch. So you can say A and go bam. And that's not a variable. Of course it's a variable. What are you talking about, Willis? Anyway, let's go see. Define. Let's see what that is. Define. Nope. jQuery. Nope. Maybe they aren't using jQuery. Good for them. Anyway, you get the idea. So, all right, that's the debugger. You also get a call stack when you're actually stopped at a breakpoint. It'll show you kind of what the path it ultimately called that particular point. You can add. I think you can add a watch that way. What's the hamburger there? Delete all the watches. Boom. There you go. That's pretty cool. Here's one of my favorite features that's been there for a while is the network summary. You do have to turn it on unlike Chrome. It just naturally runs when the tools are open. You do have to actually tell it to run. And here's all the freaking files that page loads. Good Lord. Can you believe this, guys? Hello. That is way too freaking much. Okay. It does, see, 110 files. That's sad. The average website's loading 90, which is still sad. Let's just take the images out. It should be 4 files, more or less, 4, maybe 6, plus images, and probably most of these images could probably be combined and further optimized and so forth. So, again, performance is number one. I also find it interesting here. We got kind of like a version number here, and then like another version number. I kind of wondering if they're kind of stepping on each other a little bit too much there. I don't know how they actually manage their code, but that just seems that way to me. Here's probably their images. Let's go look at an image. And response body. Yeah, it is a GIF, but it is a 1x1 GIF. How about that? I picked a 1x1 GIF. Let's see. One thing I don't like is I can't just filter by types. Yeah, here we go. Let's see. That one did pop up. Again, that's a 1x1. How many 1x1 images do they need? But normally you would actually see the image here. But here you can see the request headers, the request body, the response headers that came back. And obviously we looked at the body. If there's any cookies associated with it, you can view those there. What file actually kicked off the actual request of that. And then here's the timings on the actual file. Now, this was 3.0 forward, so it was actually pretty fast. If it wasn't 3.0 forward, then it would be a little bit slower. If you always want to refresh the server, in other words, ignore the cache, local browser cache, you just turn that on, and that'll do that for you. If you want to clear the browser cache altogether, do that. I don't normally do that. I generally just do this one. If you want to clear the cookies for the domain, force that kind of reload, here's how you do that. If you want to clear all the stuff out of the list, then that's, again, all you got to do. If you actually want to export the captured traffic, you hit that, and it'll export it for you so you can bring it up later. So that's pretty cool. It's all good stuff. Here's the UI Responsiveness tab. Now you actually have to kick off a profile. Let's see what we got here. Let's kind of go through the site one time. There you go. And let's just open up a page. Wow, for a single page app, that just took about 4 seconds to load. That should have taken about 50 milliseconds at most for this content to come up. Again, come to my performance workshop stuff. So, all right, well, let's stop this. And let's just go through this real quick. Okay, so here's like a breakdown of what happened, and there's some like points there showing us where we navigated here. There we go. I'm going to isolate in on this particular part right here. Down here is the actual visual throughput. 60 frames per second is your typical monitor's frame rate, and you want to try to match that as much as possible. So you want to use, like CSS animations, keyframes, transitions, and stuff instead of JavaScript. Don't do jQuery animate anymore. Just forget that ever existed. That's gone. Use the CSS3 to do animations. If you're going to drive anything like a single page app, changing content, try to do a request animation frame. Basically what that'll do is it'll sync it up with the actual frame rate of the screen, so you get a better seamless flow to your content. But it's really nice. It breaks down what's happening by color code. So the orange is the garbage collector coming along. The red is JavaScript. The purple is rendering. This is how long it took for the styling to be applied. Any kind of image decoding that needed to be done, you can kind of see that. Sorry for the, I've got smaller real estate here on my screen, but you can kind of see all the stuff you get kind of timings on. The key you want to do here is, find out what's causing this. So here's a timer function that's anonymous somewhere in here. And let's just pretty print that puppy, if we can. And I don't know if we're going to stay the same. It may take a little while to go through. There we go. And here we got a timeout, and it's actually calling a method here and passing some variables to it. Obviously, I don't know what it is, but that's getting called. Let's go back to our responsiveness thing. And so you can kind of see where something's being initiated. So you can maybe go address something like if you are, say, using jQuery animation and driving an animation using JavaScript instead of what you should be doing with CSS. That way you can go find it, replace the slow JavaScript with fast CSS, and make your application better. So again, the goal here is to try to be as close to 60 frames per second as possible, as much as you can. The profiler. Ooh, spending a lot of time on a profiler lately, hunting memory leaks. Let's go look and see what the memory footprint actually is. Oh, this is the profiler profile. Let's go see what we're going to do. It's a different feature than what I've been looking at. Okay, let's just go open up a new one here. Okay, went back to what is it, and we'll do this. So here's like going through all your JavaScript, kind of seeing how it was actually used. And this has been around a little while too. It's always in the Chrome tools as well. Sorry, guys. Here's a memory profiler. This is what I was thinking I was looking at. Let's go look at that. First off, we got to kick it off. And usually I take a heap snapshot up front. That's a lot of memory, guys. They're going to have a lot of leaks in here. It does take a little while for these snapshots to get created. There's a lot of data it's keeping track of. Chrome's the same way. It does take a little while for those to get created. Notice how this is just kind of ramping up here. That kind of tells me this application has some memory leak issues. There's probably timers and stuff running. And it is taking a little while. So we're flattening out at this point. Usually you'll see a spike when the heap profiler does kick in. That may be what was actually happening there. I'm not sure. But let's go do this. Let's actually go hit something else. How to use, which we already loaded, so that popped in fast. I guess they're kind of falsely caching things. Let's do that one too. And as soon as that heap snapshot finishes, we'll kick off another one here. Okay, there we go. Well, let's take another one. Then we'll come back. How's that? Well, that's doing. Let's look at this real quick. I kind of honestly hate that they put this back in here, but this is so you could go to different versions of Internet Explorer and actually use that rendering engine. Note they put 5 in here. That's if you don't have a proper doc type in your document, you fall back to Quarks mode, which, as I understand, is Internet Explorer 5. You never want to hit that. Okay, and honestly, you don't want to use these old engines. They're slower. They're not as optimized. They don't support as much stuff. Don't do it. The world needs to upgrade. Fight your local IT pro. Do the right thing. Upgrade to IE11. Here's other things. I haven't played with these enough yet, but you can tell if the profile is a desktop or a Windows phone. Remember, uh, Internet Explorer is designed to work only on Windows. It's designed to be the best browser on Windows. And quite honestly, it actually is in a lot of ways. But that's neither here nor there in this talk. You can change the user agent string to what you want. Remember, the user agent string doesn't actually identify as Internet Explorer. Traditionally, it actually would come across as Firefox now, and they're doing that because there's so many bad websites out there doing user agent string detection. And when they detect Internet Explorer, they just assume it's IE 6 or 7, which is terrible. This is IE 11. This is not IE 6 or 7. It's 2013. It's not 2007. Get over it, folks. Stop using detection. But you could like paste in any string you wanted, iPad and stuff like that. I wish it did have a full drop down of a bunch of them. I think it used to, and they changed it before release. You could also change the orientation that it's reporting to landscape profile. Change the resolution. I haven't played with these too much, but basically that's pixel densities and stuff. Here's something I love though. I actually do a decent amount of geolocation stuff, so being able to turn this on or off and designate different types is great too, because this helps you really debug things more accurately. Several times I've built geolocation stuff for people I'm working remotely for, and of course I'm here not where they want to have the location stuff work. So if I could actually put the false coordinates in, that's great. Let's go back here real quick. Oh, wow, they actually have a bug. That's really bad. There's a big bug in their app. Okay, so we've got a big memory footprint, but one thing I want to point out here, well, first it shows you how many megabytes the actual web page is using, and then how many JavaScript objects and stuff are actually being used. But what I really want to go to is the potential issues. What it's showing here are places for memory leaks, and they've got 5 just in the base of their application, and that's not uncommon. Most of these applications are going to have memory leaks. Especially if you use third-party libraries, they're notorious for memory leaks because they weren't designed for today's modern single-page application world, which is still in its infancy, folks. It's still new. Of course, we've collected a lot of data, so it does take a lot of time to actually get this up. If you've done this in the Chrome Dev Tools, it takes a little while for this stuff to pop up as well. But what it's going to do, I like this better than Chrome. It actually points out where the potential memory leaks are right up front and puts those at the high priority in the list, whereas Chrome, you have to really hunt, and you're not necessarily sure where the problem is. Okay, so we've got some document fragments that are just kind of dangling around. And then we got a root node that's a problem too. And these are identified by this little blue circle here with the exclamation mark. And then you can kind of see the object references to this particular thing. If I can get this to expand up. We don't have too much there, but you can see page handlers. Gives you a way to figure out where in your code you're creating this variable that's just not getting released, and that's going to create the memory leak. So in this case, this object is a meg in size, I think, or no, 1,000 bytes, kilobytes. Not that big, but it's still a problem. If we go over here, these are other problems. This is probably the bigger one. I've seen bigger memory leaks, so maybe this isn't too bad. But over the course of time, if this was a line of business app, this would be a real problem thing. And notice, look at this. I've got this, and look how many object references are being hung onto it. This is probably the culprit of everything else, is this particular one. I could actually dig in further and eventually probably figure out why this is being hung onto. So, but that's a real quick run through the F12 tools. I'm hoping this video is going to be able to be hosted on YouTube. We'll see. So thanks a lot, and I hope this helps you out.
We hope you've enjoyed this video, and we'll select the like button below. If you haven't subscribed to our YouTube channel, please do. And if you're interested in our newsletter, please visit lovetodev.com/newsletter.